2.3 division here, right? Yeah, we end up having a lot of questions on division. And, we do expect a lot of questions, especially with division, because it's kind of like, again, moving from addition to multiplication. I think it's a big jump, especially at the arithmetic level. And so moving from multiplication now into division is kind of another big jump, but they go together as well, just like we saw in the multiplication table, right? So division is, we've seen through the fact families that it's related to multiplication. But we're looking at it in a more direct fashion this way, while still relating it to multiplication, because when we use long division, which we're going to have to go over in this section, we have to consider the multiplication of certain parts of the problem as we do that. So here's division, just like we've seen. There's the division symbol. So yeah, it is possible to see division in fractions. And again, this does read 12 divided by 2. I mean, yeah, it does read 12 over 2. That's fine. But when we say over, we really mean divide. So if we strictly used the 4 basic operations here, we wouldn't say 12 over 2. Again, you can, but this would read 12 divided by 2. Same with this one, 12 divided by 2, 12 divided by 2. And again, long division shows it's backwards. 12 divided by 2. But long division really is related more to this question, which we did see last time. It's asking how many 2's are there in 12. And yeah, we'll go over that one very shortly. Now, the 3 parts of a division problem, we got dividend, divisor, and a quotient on that stuff, okay? So the dividend, that's how much we have. The divisor tells us how many different times we're gonna split this dividend into, right? Or how much we're gonna take the dividend and split it up into equal parts. And the quotient tells us how much those equal parts will get each. Now, again, we're going to see this in this section where it is possible to have a remainder. So like up here, we know 2 goes into 12 evenly. And if you don't know that, we will shortly. But if it doesn't go into a value evenly, that's okay. It's just you're going to have something left over in the end. It's like money. If you took... let's say you took $10 and you divided it amongst 3 people. Now, if you only have $1 bills, and that's kind of what this would be looking at, you'd say, well, each person would get $3, and I'm not doing the math here. I'm just kind of using the example. Each person gets $3, but then you'd have, kind of as a remainder or leftover, you'd have $1. Now, what you do with that $1 is up to you, but mathematically, we would just say, well, the quotient is 3 with a remainder of 1. And yeah, we got these fact families right here. We're going to look at them a little bit differently, especially since we're going to be focusing on long division today. And yes, once again, memorizing the first 12, you could say 13 if you'd like. Multiplication facts will be very helpful. Zero's not too hard. Same with the 1s or the 10s. The rest of them, it may take some experience, but if you can just, post it somewhere where you're going to see it often, and memorize these basic multiplication facts, then you're going to be good. Now, again, with long division, it does speed things up, just like it would with not long division, or just multiplication for that matter. However, the way that I'm going to be showing you today, again, having them memorized is nice, but if you don't have them memorized, what we're going to do is we're going to make a list of the multiples anyways, which is going to help us to do the division, long division. So yeah, multiplication and division, we got these fact families, right? So remember that the product of a multiplication problem, that the 2 parts that are being multiplied are factors, but the product, what you can do is take the product, which becomes the dividend, and then either one of the 2 factors become the divisor, and then the other factor becomes the quotient. So yeah, again, we got the product divided by one of the factors equals the other factors. Just like is shown in this example right here. So again, we're going to be looking at these with fact families. We're not looking at long division yet. We will, though. and I hope I'm kind of mentally preparing you for the long division that's coming, because a lot of students, this is where we find some breakdowns. Again, that's very normal. So if you feel like you're struggling, just stick with it, all right? And with enough experience and enough studying and practice, hopefully you'll get the hang of this. So the fact families, whether you use the table or not, is up to you. But what this would be, like 49 divided by 7, we would say we'd change the fact family. And then this would become, right, because 7 would be, since it's the divisor, is one of the factors. So 7 times something equals the dividend, which is 49. And, if you got these facts memorized, this is pretty nice. Or if you use the table this way, right, you'd say, well, here's that 7 right there that I got purple. Try to color code it. And then I would find one of the products of 7, which is 49. Well, there it is. And so then I would follow it up to the other factor, which is 7, which means it's 7 times 7. So 49 divided by 7 is 7. Or again, in other words, 7 will go into 49 7 times. Or if you split up 49 among 7 equal parts, each part would get 7. I hope by me using these different types of terminologies, it's not over confusing. I know it can be confusing, though. But try to listen to just the one way that works for you, and then just ignore the rest of the ways. All right, so 48 divided by 6. Again, the divisor here is 6. It has to be one of the factors, so it'd be 6 times something. Would then equal the dividend, 48. Again, I did change the operation, though, right? It was a division problem. I changed it with a fact family into multiplication. So then this becomes 6 times something is 48. You're just using the same method that we did on that last one. There's the factor 6. And then I follow this row till I find a product of 48. And then the other factor becomes, well, the other factor, but that is also the quotient of 48 and 6. So 48 divided by 6 equals 8. So again, if you have those basic math facts, the multiplication facts memorized, that goes pretty quick. All right, 72 divided by 8, same thing. So on this one, would say, so 8 is one of the factors, right? So it's 8 times something equals the dividend, which was 72. So again, if you got that memorized, you know right away what it is. If not, then we can use the table. So 8, I would follow that to the product of 72. And then I followed up this column, which tells me the other factor, which is, in this case, 9. So 8 times 9 is 72, or 72 divided by 8 is 9. And again, we see that relationship in that fact family right there. So this last one, same idea. All right, here we go. That seems to work better. So 18 divided by 3, right? So 3 is one of the products, so it's 3 times something equals our dividend, which was 18. So 3 times what is 18? And yeah, some of you would know this right away. If not, you can use the table. Yeah, it's 3 times 6 is 18. So 18 divided by 3 is 6. Now, again, I may be taking more time on these than some of you need. But for those of you that don't need it, thank you for your patience. For those of you that need it, hopefully that you find that kind of helpful, at least. So long division. This may be more writing than we need. Let's see what it says. Long division is a different way to set up and solve a division problem. But we've seen this before, right? Remember, it's the dividend. It goes inside the, divide sign, I guess. And then we got the divisor on the outside, which, again, it just kind of sets up differently. Usually it's like if we saw the division symbol, you'd have the dividend here and then the divisor in the second position with the division. So keep in mind that it does reverse that. And I think I talked about this before, but if you're from, and I found this more with my students that come from Latin America, where it's not actually reversed, but it's shown in a different way, even though the technique is the same. So if you use that method, it's perfectly okay. I would never look at something like that and be like, oh, you're going to lose points because you didn't show it exactly like I showed it, all right? So if you have that method and you want to do it that way, you can almost kind of ignore the way that I'm showing it. But again, it's up to you, okay? So long division breaks up division of large numbers into smaller values to divide. So the nice thing about long division when we have to do it by hand, right? Because if we're using a calculator, we're like, hey, this is pretty sweet, it works pretty fast. But we can't use calculators in this class. So by using long division, it automatically breaks these, what can be these really long math problems, into smaller, more manageable problems, okay? So that's good for us. And it does it automatically, whether we like it or not, as long as we're doing it correctly. We will use multiplication tables to solve, and that'll come into play as we see some of these examples. So divide the highest place value of the dividend by the divisor and move to the right. So, and this is where where we find some confusion, because generally when we were using addition, subtraction, and multiplication, we said, hey, start as far to the right as you can go and then move to the left, right? And I'm talking about place values. You say I'd start in the ones place value, then the tens, then the hundreds. With long division, you're going to start with essentially the front end of the number. I'm not talking about front end rounding, but just the number farthest to the left, or the place value farthest left, and then we move to the right. So that's how long division is going to break this up into smaller, more manageable problems for us. And again, the question is, well, how many times does the divisor go into these numbers? Well, long division says, how many times does the divisor go into the place value, and then we tack on more place values if they are needed. So once we figure out what that value is, whatever that quotient is by part, then we multiply that by the divisor. That's how much was used up or divided from, right? So we would say, okay, you could have some left over, and that's why we subtract that product. So, again, we would say the quotient times the divisor, that's the product it's talking about right here. You subtract that from the values or the place values we used from the dividend, and whatever's left over, we start tacking on the other place values to whatever's left over. So enter an empty quotient spaces with 0. Yeah, now I kind of recommend doing this even if the first place value is 0. Some students fail to do that, but I think it's important to see that because it lines up the place values as we go, and then we know what place values we've used as well. Again, I feel like that was kind of a long lecture on long division, and so that may be confusing offhand, right? But once we see some examples, hopefully this kind of will make more sense. So here we go. We're going to divide these. It didn't say we had to use long division, so if you're like, hey, I can do this, and I can do it pretty quick, okay, that's fine. I'm not going to. I'm going to use long division because that's what we just learned, right? So I'm going to set this up, and I got two parts. We got a dividend, and we got a divisor. Well, if we remember from long division, which that's not perfect. In fact, that's not even so pretty, but I hope it works. The dividend goes inside that divide sign right there, right? So I'd say 3,100, no tens, and then a 2, right? And I have split those up on purpose with a little space, just kind of like we did with the other 3 basic operations that we've used so far. And then the divisor is on the outside here. Okay, so this is how this sets up. And just like we said on that last slide, I'm going to start as far to the left place value as I can, which for this problem is the thousands, the 3,000. Then I'm going to move slowly to the right as we go. All right? So, just like I said before as well, long division splits this up into smaller, more manageable parts, which means I don't have to focus on the rest of this. Right? We know it's there. There's still that 102 there, but I don't have to worry about it right now. Now, as we move forward, we will, and it's possible that I could need them, but I'm just analyzing first the 3 and the thousands place value. Okay, so I would say, well, 3, I'm not really saying 3 divided by 3,000 because, again, that's the purpose of splitting this up. I'm looking at 3, well, this 3 divided by this 3, right? How many of these purple 3s can I fit into that red 3? Well, I can fit 1 in, okay? There's 1. Now, let's say that we didn't have we couldn't tell for sure how many 3's went into 3, all right? And some of you may feel like I'm being sarcastic here. I'm not, okay? Well, what I like to do, especially when I'm doing these by hand, is I like to have kind of a multiplication chart off to the right here, which is going to help me to figure out which multiples I'm looking at, okay? So whether you have the 3 multiplication tables memorized or not, this is the way that you would do it. Now, I'm going to do this with the basic number. I probably won't with 5, although I'll still show the table or the set of multiples of 5, okay? So I'd say, okay, my first multiple of 3 is 3, right? So there's my first multiple. And you could, some students is even like, hey, there's my first multiple. Put a 1 next to it, however you want to do it. The second multiple would be 3 more than that. Well, 3 plus 3 is 9. I did 3 times 3. 3 plus 3 is 6. Well, that means that 6 is the second multiple of 3, right? And some of you know that I'm just making the table here, or from the multiplication table, but 6 plus 3 is 9. That would be the third multiple there. 9 plus 3, that would be 12, which is the fourth multiple. Now, you may wonder, well, when are you going to stop, Sal? Well, I'm going to stop when we get to 9. That's all we need. Once we get to 10, we don't need to worry about it because it would be a double-digit number. So 12 plus 3 is 15. That's my fifth multiple. Plus another 3, that'd be 18, which is the sixth multiple. It's not a good 18, but it'll still work. Plus 3, that's 21. That's my seventh multiple. I should have been writing smaller from the beginning. That's all right. So 21 plus 3, that's 24. That's a 4 right there. That's the eighth multiple. And then plus another 3, that's a 29. Dang it. Hope that's enough. That's a 27 right there. That is the ninth multiple, okay? And again, you only need the first 9 multiples. Now, did I even have to go that far? I don't know. Sometimes if the number's big enough or the divisor is big enough, I would stop at like 5 and then see if I need more after that. So here's where this comes into play, all right? So I already did, for example, this 3. How many of these 3 go into this 3? Well, it was just 1, right? It was 3. There's that 3 right there. So there's the match. It's 1. This is my first multiple. So 1 times 3. Here's how this works. I take the quotient and multiply it by the divisor. And 1 times 3 is 3, right? And then I subtract that from the 3 that I took from. So that's 0 right there. And now, let's see if I can move that. Now I go to my next place value, which is the 1 in the hundreds place value. So 1 in the hundreds place value, you can check the chart over here that we just made. 1, 3, 6, 9, 12, 15, 18, 21, 24, 27. It's not in this chart, which means that a 3, I would say right here, it just doesn't go into 1. So I put a 0 there. I forgot a step. I apologize. I should have dropped this 1 here so that I know that I'm just focusing on the 1. All right. Well, I'll try to remember that on the next problem. But 3 won't go into 1, right? Which is why we got this green 0. So what I do is I drop the next place value to make this number bigger. And hopefully the 3 will go into this next number. Well, it's a 2-digit number, so it should. And so I'd say now, again, I'm just looking at this 10 right here. I'm not worried about the 3,102 anymore. Only the 10 that I have here in orange. And if it helps you, you can erase that 0, make it a phantom 0 right there. But now we're asking ourselves, how many times does 3 go into that orange 10 that I put on the screen? Well, we can go to our trusty chart that we made over here. It's 3, 6, 9, 12. Well, 10 is between 9 and 12. 10 is not as big as 12, so it can't be 4. It looks like it's going to go into 10 3 times. Okay. So that's 3. Now what I'm going to do is I'm going to take this 3. That's our quotient that we just got from 3 and 10, right? 3 times 3, that would be 9. So I put that under the 10, and then I subtract it out because that means the green 3 multiplied by the purple 3, that's 9. That's what I took out of the 10 that we just had to split up. So 10 minus 9 is 1. And again, you can always ask yourself, well, will 3 go into this number? Because if it will, then you didn't use a big enough quotient, right, up here. 1 is small enough, so that's good. It's smaller than 3. But it's not big enough for 3 to go into. But if I tack on the next place value, which is the 2, yeah, it will go into 12. So I look at my chart, and I need to find 12, right? 3, 6, 9, 12. There it is. 12 is the 4th multiple. So I do the blue 4 times the purple 3. That means it used up all 12. And there's 0, right? And that usually, once you get done with the ones place value, especially while we're not dealing with decimals, that would tell us how much remains or how much is remaining. And since it's 0 in this case, that means that 3 goes into 3,102 evenly. It will go into 3,102 1,034 times. Okay, so that number here at the top, 1,034, this is our quotient, our final quotient. So the difference between the ones right here, right? Like this one, when I dropped it, was just a 1 by itself, and that was all that I had from this place value, so I had to put a 0 there. When we got the 1 in blue right here from the 10 minus 9, I had already put the 3 in that 10's place value, which this 1 is really in that 10's place value. And since that's the case, it means that this 1 in blue that I had, it was left over from what I had already used in this place value. So I didn't need to put a 0 here in the 10's place value. I already had a value. And so I needed to make it bigger by taking now the 1's place value. So when I look at what is now 12 after dropping the 2, that means that I'm now working in this next place value. I'm going to put this one over here just so I have more space to work with. But I'm going to have to do my work on the left for this one, okay? So just identifying the two values, right? We got a dividend, that's the 1,520, and a divisor. So in other words, this division problem is asking, how many times does 5 go into 1,520? Or again, if you took 1,520, again, I would like to say dollars. If you took that many dollars and split it amongst 5 people, how much would each person get? So let's find out, right? So I take my dividend, 1,520, and use some long division here. I don't know if that was a better long division symbol, but it'll work. We're going to divide this by 5. All right, so we have this written up. We just need to do the long division. This will tell us the final total quotient. So let's see if this, let me do this time. So I'm going to cover up the other place values, right? Again, we always start with the place value farthest to the left, which in this case is in the thousands. Now, the problem with this at this point is whether we have the chart up or not. 5 won't go into 1, all right? So since 5 will not go into 1, and I'm going to make the chart here in a moment, but 5 won't go into 1, which means that it will go into 1 exactly 0 times. It's just not, 1 is not big enough for 5 to go into. Okay, you could say, well, if I had a 1, could I split it up amongst 5 people? Well, okay, if that's a dollar bill, you could technically split it up into cents, right? Quarters and nickels and dimes and so forth. But if it was just a dollar bill and you had to split it up, you'd have to start tearing up that piece of paper, which kind of makes it worthless if it wasn't already in the first place. So we would say in this case that, well, yeah, we're just going to put a 0 in that place value. So since we have done that, then we have to move the place value over and look now, instead of it as 1, we now have to look at this as 15, kind of like how we did in that last example with dropping the numbers. Well, now before I move on, I'm going to make that chart, okay? And again, I'm not going to show the addition, although you could. It'd be really nice if we get to have our 5 multiplication tables down, right? Just like all the other ones, 0 through 12. So this would be 5, 10, 15, 20, 25, 30. Hopefully I gave myself enough space. 35, 40. And again, I only need to go to 45. You can say 50, but we should never have to be writing more than 1-digit values in our quotient. All right, so that's our first 9 multiples of 5. They're correct even if my handwriting's poor, but one of my zeros kind of looks jacked up. In any case, moving forward on this one, I'd say, okay, 15, right? I'm seeing how many times does 5 go into 15? Well, that's where I use my multiplication table, and I'd say, well, there's 1, 2, 3. It's, 15 is that third multiple. Now, again, you have to be careful because sometimes these values will drop in the middle of the multiples, and you have to go with the next one down, just like we did on the previous problem. So 5 will go into 15 exactly 3 times, okay? Now, just like we discussed on that last problem, it's like saying, okay, you have 15, you're going to distribute it equally amongst 5, so how much would each of those get? Well, that's where the green 3 comes in. That's where that's our quotient right there is 3. Well, that means that you distributed all 15 of those to the 5. So that's why we have to subtract these out. And it would leave us with nothing left over. Now, that's just with the thousands and hundreds place value. So the 3 right now, of course, it's representing hundreds. But we have to be careful because we have to consider these other place values, okay? So there was nothing left over from the thousands or hundreds. And yeah, it's common just to show this with an empty space right here. It's pretty much just a phantom 0. And so what I need to do now is I need to look at my tens place value and just drop it. All right? That's a 2. Well, and again, this is related to what we saw last time. This 5 is too big to go into 2, right? You can't take 2 $1 bills and split it up amongst 5 people, just the paper, equally. So that means that I do need a 0 to hold that place value because, again, the 2 is just not big enough to split the 5 up. So I need the ones place value. So let's just get rid of this garbage. And I'm going to drop that with the tens to make it now 20. All right. So keeping this 0 here is crucial. Let's say that we didn't, right? Let's say, okay, well, whether we forget or we just don't know how to do it yet, it's okay either way right now, right? Because we're just trying to get used to this. But you'd say, okay, well, okay, I know I need to make this 20 so that it's big enough, right? Okay, well, now when you do the distributing of the 20, right, would say, okay, it's 1, 2, 3, it's the 4th multiple of 5, right? So you know you're dealing with just the 4th multiple, but now it's a question of which place value do you put that 4 into? If you don't have that 0 to hold the tens place value, are you going to put the 4 in the tens place value? Or would you put it in the ones place value? And again, this may come with some experience, but we should know since we're dealing with the place value farthest to the right that we're dealing with is the ones place value, we should know that it goes in, the 4 needs to go in the ones place value, right? Now, if we don't put anything in the tens place value, what number do we really have right here? This is really 34 without something to hold the tens place value, right? Which is why we need that 0 right here. Because it's not 34, it's 304, which is very, very different, okay? The last thing I need to do on this problem is just make sure that there's nothing remaining. There could be. Some of you are like, well, I know there's not. That's okay, too. So the last thing I would say here is I take the 4, right? Now, that's how much each of these 5 people got. Again, I'd be looking at this as dollars. Each person got $4. 4 times 5 That's 20. So when I subtract this, 20 minus 20, it's just 0. You can put 2 zeros there if you'd like. So that's how much is remaining. There's just 0 remaining in this one, which is okay. And in fact, going back to that, we got 0, 3, 0, 4. I'm just going to make that a clean 304 right here, which is our final quotient. So yeah, if you took $1,520 and split it up amongst 5 people, each person would get $304. Now, for both of those problems, I kind of made those lists on the left so that we can kind of refer back to those. Again, if you got the first several multiplications memorized, that goes a lot faster. You don't necessarily need to write those out to the side. But once we start dealing with bigger divisors, you may find that it's very helpful. So division and remainders, again, we had some remaining in those last few. Sometimes we're not able to divide them evenly, just like we talked about, right? Like if you had 10 bucks, 10 $1 bills, and wanted to split them just the paper, right? We're assuming that you can't split them up into pennies. Now, what the heck? Let's just use pennies. If you had 10 pennies and wanted to split them amongst 3 people, each person could get 3 pennies, but then you'd have 1 left over. What do you do with that penny? Well, in math, we just say that it's some value that remains. Although later on in future mathematics, just understand that we can't do something with the remaining value, okay? In the homework, you'll see 2 separate boxes, one for the actual quotient and then one for the remainder. And just like we saw with those last 2 problems, it is possible to see a 0 remainder. And so if that happens with those types of problems, you just put a 0 in as a remainder. So yeah, like this example, we cannot divide 53 Hot Wheels evenly amongst 10 kids, right? Well, I like Hot Wheels, and I'm not a kid, but I like them. So we can give each kid would get 5 Hot Wheels, but then would have 3 left over that remain. Again, we call those remaining in math. And again, we're not saying that we're doing anything with it. We're just saying that they are remaining from what we had started with, which would have been the 53. If this were a problem on the homework, right, it'd say, hey, you got 2 boxes, one for the quotient and one for the remainder like this. But you'll find that we're always keeping track of the remainders as we go. It's just that if there's other place values farther to the right, we're actually using those remainders to continue distributing or splitting them up. Now, in this problem, right, that we just did with the Hot Wheels, you'd put a 5 in this box because that's the quotient, and then the 3 that remain. So we should see some remainders in these, maybe not. But since it wants a remainder, again, you'd be filling in 2 boxes, whether there is one or not. If there's no remaining, 0 remaining, then of course that remainder is 0. So let's use some long division on this stuff. So yeah, we got our dividend and we got our divisor. I'll set this up, 8,882. And we are dividing this by 6. Okay. Oh, I should make that color-coded. There's the 6. All right, and I'm going to show my multiplication tables of 6 all the way up to 9 here on the right. And we should have these memorized. So 6, 12, 18, 24, 30. That's the 5th one. 36 is 6. 42 is 7. 48 is 8. And then 54 is the 9th multiple. Okay, so I've got a good list here, and again, that just may be in your mind because you have the 6 multiplication tables memorized, and that's good too. So I would start here in the ones place value, and I'm not going to cover these ones up here, partially because I'm just having trouble with the technical issues of just moving the stupid box. But in any case, we have to put these out of our mind and just focus on this individual place value, the one farthest to the left. And again, we are in the thousands place value. Hopefully that's okay. So I'd say, okay, 6 and 8, right? How many times does this purple 6 go into this red 8? Well, 8 is between 6 and 12, right? So I would have to know, again, you'd go to the lower of the 2 values, which is just 6. That's my first multiple. All right, so again, if you took 8,000 and split it up amongst 6, each of them would get 1. So you've just used up, you just took out 6 of the thousands from the 8,000. And so how many are you left with? Again, this would technically be a remainder. It's not the final remainder because we know we can split up 2,000 among 6 as well. But continuing to the right here, the next place value is the hundreds. That's the 8 there, another 8. And again, I'm just focusing on the 6 and the 28. How many times does 6 go into this 28 right here? Well, I can go to my multiplication table, the chart that I have set up over here. It's 6, 12, 18, 24, 30. 20 is just below 30, so I'd have to go to the previous multiple. That's 24. That is 1, 2, 3. That's my 4th multiple there. So that's my 4th multiple. So I put a 4 as my quotient. So then I find the product of 4 and 6, right? That's how much was used up of that 28. And so 6 times 4, there's 24. I just pretty much looked at my multiplication table over here, the chart. I got that 24 right there. So I'm subtracting 24 from 28, and that's how many hundreds are left over. There's just 4 hundreds left over. Let me extend this bar. Hopefully that kind of helps us to keep organized. Well, now, the 4 is not big enough, so I got to drop the 8 from the tens place value. So I now treat this as 48. Well, it's nice. 48 is one of the multiples. I can find it right there in the chart. And which multiple is this? 1, 2, 3, 4, 5, 6, 7, 8. So that's the 8th multiple. So that's my quotient here. And 6 times 8, that's exactly 48 right there. So I'm going to take that out of the 48, and I would have 0 remaining. Let's extend this line. And so I'd be looking to drop the 2 right here. I don't really need the 0 to hold that place value there. And this is where things get a little interesting for us because, well, I don't have any other place values to borrow with for the 2 in the ones place value. I mean, once you start dealing with decimals, you can, but I'm not worried about that right now. I'd say, well, 6 doesn't go into 2, right? Now, that means that 2 is what we're going to that's what we're going to have remaining. But it also means in the ones place value, the 6 won't go into the 2, so I have to put a 0 to hold that place value. Otherwise, that final quotient is just going to read as 148. But it's not 148, it's 1,480. But this one has a remainder of 2. So again, on the homework, you'd say, all right, you got your quotient, 1,480. You type that into the 1 box for the quotient, and then in the remainder, you're just going to put the 2. So you can take 8,882 and split it up into 6 groups equally. That'd be 1,480, but if you did, you'd have a remainder of 2 of whatever it is that you're splitting up. Right? So this is 88 divided by 8. Actually, this is one of our facts, but I'm going to show it with long division, right? So this is, remember the top number here, that's our dividend. So it's really 88. And then our divisor is 8 right there. So it's 88 divided by 8. And yeah, remember the original question on this one wants not only the quotient, but the remainder as well. So for this one, I'm going to start with just the 8 and the tens place value. And we don't really need a lot of multiples of 8. You can write them down if you'd like, but some of you can see this isn't, it's not going to be necessary for us. So like the purple 8, how many times does it go into the red 8 right there? It's just once, right? Because that's our first multiple. So over here, that means that you took those 8, the 8 tens, and distributed them evenly with 8. So you used up all of them. So there's nothing remaining there. So I'm going to get rid of that 0 because we don't really need it. Which also means I'm going to drop this next 8 in the ones place value. And yeah, 8 for this 8 as well. It's just going to it one time, which then gives us a quotient of 11. But yeah, 1 times 8 is 8. So whatever I get, again, after subtracting from the ones place value, that's what I get remaining. There's just nothing remaining on this one. So it's an 11 with a remainder of 0. And this is kind of how it's written. I guess maybe it's still shorthand, but It's 11. The R is the remainder of 0. All right, we want quotients and remainders on these ones as well. So again, I may speed this one up just because I feel like I'm running out of time, but I'll still need to identify. We got our dividend and our divisor, so this is 972. Maybe I should have given myself more space, but that should work. Divided by 6, the divisor. So our multiples of 6, I know we've listed them already. We can still list them again. 6, 12, 18, 24, 30. That's 4 right there. 36, 42, 48, 54. So there's our first 9 multiples, which is all we'll ever need. That's a maximum amount right there. And I would say, okay, starting with hundreds place value, the 9, right? I'd say, how many times does 6 go into 9? Well, 9 is between 6 and 12, which means that 6 goes into 9 once, right? So if you took 9 and you split it up among 6 evenly, each of those would get 1, but this is where we get the remainder on that. 1 times 6 there is 6. 9 minus 6 is 3. So you'd have 3 of the hundreds left over. And 3, again, 3 by itself is not big enough for 6 to go into. So I need to drop my next place value, the tens place value, and make this 37. So 37, it's not on my list, but it's between 36 and 42. It's just right above 36. 42 is too big for it, so it's just the 36 right there, which is the 1, 2, 3, 4, 5. It's our 6th multiple. So 6 will go into 37 6 times. Okay, and 6 times 6, that's that 36 that we just found in our chart. So subtract that out, which means that if you distributed the 37 evenly among 6, then you'd have 1 that is just left over. It's just hanging out there, right? But for us, we get to drop the 2 to make it 12. Oh, okay, this is good. I see 12 in the list. It's exactly in the list. It's our 2nd multiple. So that's our quotient. So 2 times 6 is 12. And when I subtract that, I get 0. That's remaining. So again, the 2 boxes here, you got the quotient, 162, and then you got a remainder of 0. Now, we are indirectly using the fact family on this, but having it applied in a long division like this, sometimes it's not so clear how we are using it. So it may be better just to think of this, again, you're using up part of the hundreds, tens, and ones, and as you use them up, that's why we're subtracting, and then whatever's left over, that's what we have left to work with. So division by 5, by the way, division by 5, 10, and 1. I love dividing by these 3 values because they're extraordinarily convenient, right? Because, well, maybe it's just for me, and it could be the case. So if you feel like you're struggling with the 5s, don't worry about it, okay? But once you see, right, counting by 5s, generally, for most people, it does come a lot faster than, counting by 7s or finding multiples of 7. All right? Now, we still can. You could say, well, I'm going to list my multiples of 5 over here. That'd be 5. That'd be okay. 5, 10, 15, 20, 25, 30, 35, 40, and then 45. That's our 9th multiple. And writing these out with long division, it's really 524 divided by 5. I kind of set this one up so that the quotient would fall where it should in the problem. All right, either way. So I start with the hundreds place value, right? 5 goes into 5. There it is. It's right in our list of multiples of 5. Goes into it once. So that means those 500 were all used up. We took those out and distributed them already. Each of those gets 1, so we don't have anything remaining. That's okay. It's a 0. I'm going to just get rid of that. So I'm just going to drop the 2 directly from the tens place value. Now, whether you have the 0 here or not, this is still 2, and 5 is too big to distribute, or 2, we can't distribute it equally with 5, right? It's too small. If you distributed it into 5, then, well, no one's going to get anything from that, okay? So whether you put the 0 here now or later is really up to you. I'm going to put it in now because the 2 is too small, right? And if you can get used to putting it in now, then hopefully there's not as much confusion on where you place the actual quotient that we're going to need. So the 2 is too small, which means I need to make it bigger. So I drop the next place value from the 4 from the ones place value. And 5 goes into 24. 25 is too big, so I got to go down 1. And that's the 1, 2, 3, 4th. That's my 4th multiple. The 20 is. And 4 times 5, of course, that's the 20 that we just found in our chart right there. So 24 minus 20 is 4. And we just used the ones place value, right? So our actual quotient we just found, it's 104, but it has a remainder of 4. All right, find this quotient and remainder. This is a bigger problem. It's a bigger number, right? 42,149. So let's go ahead and put this in. We got this is our dividend, the 42,149. And I know we've seen 6 before. That's okay. But we are dividing by this divisor 6. So let's go ahead and list our multiples of 6 over here. 6, try to write that a little better. 6, 12, 18, 24, 30, 36, 42, 48, 54. There are our first 9 multiples of 6. Well, we would start here with the 10,000s place value, but the 4 is too small for the 6. So again, just going back about what I said in that last problem, that means that I'm going to put the 0 there to hold that place value, just so we know that there's nothing, we can't split this 4 up evenly with 6. It's just too small. But if I make the number now 42, yeah, that's big enough. In fact, it even falls in the list right here, 42 right there. So 6 will go into 42 evenly. That's good. What multiple is that? 1, 2, 3, 4, 5, 6, 7. That's our 7th multiple. So I can put a 7 here. And after I get the 7 there, we don't really need the 0 to hold that place value. So you're welcome to erase it here. You're welcome to keep it there. It's not really going to matter. Just don't type it into the answer. I don't think it wants to see the 0 there if it's in the front. So I got 7 times 6 from our multiplication table. That was 42. So I take that out, right? We used it up, which is 0. Well, at 0, we don't really need it. It was all used up, which means I can go to my next place value in the hundreds, which is a 1, and consider it. So 1 is too small for 6 as well. So in this place value for the hundreds, yeah, just using the 1 by itself, it's not big enough. So I got to put a 0 here as well. Now I need to put the 0. I need that there because it's holding a place value, which we actually need. So since the 1 isn't big enough, I'm going to go to the next place value, which is going to make the number just a little bit bigger for us to use. And 14 is big enough for the 6 to go into. 6 will go into 14. Again, 14 is just about 12. It's below 18, so that's the second multiple. 6 will go into 14 2 times. And 2 times 6, it should be this multiple, which we've already seen in the chart. There's 12. 14 minus 12 is 2. So then I can take this 9 in the ones place value because the 2 isn't big enough, and it shouldn't be because we already used the place value. We're going to drop this as a 9 to make this a 29. So 29, where is that in our multiplication table? It's just under 30, which means we've got to use the next multiple down, and that's our fourth multiple. We've seen this one already tonight. That's okay. That's our 4th multiple here. 4 times 6, that's this multiple here, 24th, the 4th multiple. Subtract, and we had 5 left over. So there's no other place values to drop to make this 5 bigger, right? The 5 is too small for the 6 to go into. So we've already found the answer. We just need to identify it, right? So I'd say, all right, I got my quotient of 7,024. And then down here, that 5 that was left over, that's our remainder. So the final quotient here between 42,149 and 6 is 7,024 with a remainder of 5. Multiples, the product of a number and a natural counting number. Yeah, that's a multiple. We've already seen multiples and we've listed them. That was great. Dividing with large numbers, memorizing multiplication tables to 12 is very nice and it will help out a lot. But if we look at numbers beyond 12, because we don't actually expect you to memorize those, then it's like making those lists, which we were doing on those last few problems, which I think is going to be key. And making those is key for us to really speed up the process, but also for us, it gives us something to refer back to as we do the problems, all right? So, but again, since we expect you to memorize the first 12 multiples, anything beyond 12, we're just going to list and make ourselves. So, dividing. Yeah, the two problems. Let's start with this first one. All right. So, once again, we have our dividend, 7,921. And we are going to divide this long division with 89, which is our divisor. Now notice I'm not really splitting up the 89 like I am with the 7,921 because we don't really need space between these. I just got to know what the multiples of 89 are, which is what I'm going to do next, okay? So always the first multiple is just itself, right? Anything times 1 is itself. So I'm starting with 89, but I'm going to add 89 to find my second multiple. Okay, so, well, 89 is my first multiple. 89 plus 89 is my second multiple. So 9 plus 9 is 18. Carry the 1. And then 1 plus 8 is 9, plus 8 is 17. So my second multiple here is 178. Then I'm going to add another 89 to get my third multiple. So 8 plus 9 is 17. Carry the 1. 1 plus 7 plus 8 is 16. 1 plus 1 is 2. So that's my third multiple, 267. And then I need, well, looks like I need another multiple. So let's add another 89, which would then be the fourth multiple. And I know I may be going faster than some of you would on a problem like this one. But again, I'm kind of pressed for time here. So 7 plus 9 is 16, carry the 1. 1 plus 6 plus 8 is 15, carry that 1. 1 plus 2 is 3, so that's my fourth multiple. Then our fifth multiple, plus another 89 here. 6 plus 9 is 15, carry the 1. 1 plus 5 is 6, plus 8 is 14. 1 plus 3 is 4. 445 is our fifth multiple. May need more space on this, but plus another 89 here. I'll try to write smaller. 5 plus 9 is 14, carry the 1. 1 plus 4 is 5, plus 8 is 13, carry the 1. 1 plus 4 is 5. 539 is our 1, 2, 3, 4, 5, 6th multiple. And then I need another multiple plus another 89. So what is this? Seventh multiple. 4 plus 9 is 13. Carry the 1. 1 plus 3 is 4, plus 8 is 2. That's 12 rather. 1 plus 5 is 6. So that's our next multiple. 1, 2, 3, 4, 5, 6, 7. Well, I really should only need 2 more. Plus another 89. But yeah, I need more space on this. So 3 plus 9 is 12. Carry the 1. 1 plus 2 plus 8 is 11. Carry that 1. 1 plus 6 is 7. 712. So that's our 8th multiple. And again, we only need 9 multiples. So adding another 89 should finish this off. So 2 plus 9 is 11. Carry the 1. 1 plus 8. 1 plus 1 plus 8 is 10. Carry that 1. 1 plus 7 is 8. All right, so that's my 9th multiple right there. And yeah, it looks like we're going to need all 9 of them, whether you realized it or not. Now, that may have taken a long time, but it sure beats the heck out of trying to think, well, what is the 9th multiple of 89, right? And then having to multiply those out one by one. But if I have these listed out like I do here, it definitely, at least for me, it makes things more convenient. So are you required to write these charts out? Of course not. You're not. Okay, so if you're like, I'm not going to do those charts, don't. We're not going to force you to do that, okay? Now, we are going to need a lot of multiples on this thing because 89 will not go into 7 in the thousands place value. In fact, it won't go into 79 in the thousands and hundreds place value. So I got to start with 792. So I look at my multiples. 792 is just below 801. That's my 9th multiple, which means that 89, it's not going to go into 7. It's not going to go into 79, but it will go into 792 8 times. And then I just list my eighth multiple here, 712. That's what 8 times 89 would be, 712, which I can now subtract. So I take 2 minus 2 is 0, 9 minus 1 is 8, and then 7 minus 7 is a 0. Just make it a phantom 0 here. So I have 80, and yeah, that's smaller than 89, which it should be. But if I drop the 1 from the ones place value, it's going to make that 801, which is exactly our ninth multiple. So I'm just going to list that there as my quotient. The 9 times 89, that's 801. So when I subtract it, I just have 0 remaining. Who knew? 89 went into 7,921 evenly. Again, you'd have the two parts of your answer. You got the 89 is the quotient with the remainder of 0. All right, so I'm going to do the same thing with 13 because we may not be familiar with our 13 times table. I know I'm not. So there's our first multiple, 13, of course, just by itself. Add another 13, and that's our second multiple. That's 26. So I'm just kind of marking these as I go so I know that it is a multiple. And then I add another 13. That's my third multiple. Looks like that would be 39. And then add another 13 here. I was going to make that 12, carry the 1, 52 it looks like. So that's a fourth multiple. Add another 13. There's a 5. 5 plus 1 is 6. So 65 is our fifth multiple. And then I'm going to do the seventh multiple here. 5 plus 3 is 8. 6 plus 1 is 7. But I'm going to stop here just because I don't know if I'm going to need all 9 multiples, okay? But I do have up to the sixth multiple. And if I need more, then I'll address that. But I'm going to take my dividend, 2,218, and I will divide it with 13, my divisor. So I've got some multiples here, and yes, 13 will not go into the 2 in the thousands place value. So I have to look at this as 22 now. And 13 will go to 22. 26 is too big. That's the second multiple. So that means 13 will only go into 22 once. So 1 times 13. Again, you distributed those out, so we're subtracting. And 22 minus 13, that's 9. Just got to carry the 1 there, borrow from the 1 there. 12 minus 3 is 9 right there. So that's how much we have remaining, and that's okay. 9 isn't big enough for 13, which we shouldn't expect since we're using division here. So I'm going to drop the 1 there from the... to make this now 91. So it looks like 78 is just not big enough, so I do need the next couple multiples, it looks like. Add another 13 there, there's a 1. 11, carry the 1 there's 91. Oh, that's exact. So that looks like it's the 1, 2, 3, 4, 5, 6, 7th multiple. So 13 will go into 91 exactly 7 times. 7 times 13, since it's exact from our multiplication table, we know it's 91 that we're subtracting, and so we have 0 remaining. But I still have the ones place value to deal with, the 8 in the ones place value. So I'm just going to look at this as 8 here. Well, 13 will not go into 8, so we'll go into 8 0 times. 8 is just too small. So that gives me this quotient, 170, and also with a remainder of 8. Now, notice I did not, what is that, the 7th multiple of 13? I did not go all the way up to 9. And, you know, depending on how motivated you are, you can always do it with the first 9 if you'd like. But if you ever find that you haven't got enough value, like we did in this case, you know, you could just keep going if you'd like. So what was that, 104? And then the last one, 117. Yeah, that looks like it's the 9th multiple, but we didn't need those, so we only just kind of looked at what we needed. So division by 1, anything divided by 1 is itself, and we have seen that. We saw that in the first section of this unit. So we'll remember that. We need to remember that, especially when we look at rounding, which is coming up. So division with base 10s, and we've seen this before. Any zeros that match in the divisor and dividend, as far to the right as we can go, they just essentially cancel each other out. Like those zeros would cancel each other out, and then these zeros would cancel each other out, which then simplifies this then into just 30 divided by 5. Yeah, and 5 will go into 30 evenly, whether you do it long ways or not, right? I'd say, well, let's just change it because we've just used a fact family for this one. 5 times what is 30? It's 6. I don't know if that was a better 6 the second time, but it still works, okay? So what about problems like these? Well, it still is just the same as that one that looked like a fraction. It's still dividend divided by the divisor. And sure enough here, we got a 0 from the 10 and a 0 from the 380. And again, we're just canceling these out, which means that we're really looking at just 38 divided by 1. But we remember, just from a couple slides ago and from last time, anything divided by 1 is itself, so it's just 38. That's our final quotient on this one. So again, that's a nice technique to use if you're looking at big numbers, but they end with zeros like these ones do. So same thing here. We got a 0 from the 30 and a 0 from the, what was that, 1,200,000, which now changes this into 120,000, but just divided by 3. Now, you could use long division to do this, but if you went over what we did last time, I'd say, look, take these 4 zeros and just tack them onto the answer, right? We'd say, okay, 1, 2, 3, 4 zeros, which means really all we're looking at is 12 divided by 3. Now, this does come with a little bit of background knowledge of knowing that 12 goes into 3 evenly, right? So if I change this using its fact family, it'd be, well, 3 times what is 12? And then we know then that that is 4. So this 4 is what we're really tacking onto the zeros to make it then 40,000. So even if you took the original 1,200,000 divided by 30, it'd still be the same answer, 40,000. So division with rounding, again, do the rounding first and then use the division. By using rounding with division, we'll see some of that last property we just saw with dividing with tens. It's just going to be crossing out some zeros usually. All right, so both of these we want front end rounding. So we'll start with that 407 divided by 22. All right. So let's use some front end rounding just to start out with. So I'd start with the 407 for me, even though you could start with the 22. In the front end, I got the 4 just to the right is 0. Since it is a 0, the 4 is just going to stay 4. We don't need to add to it. And then these other 2 place values become zeros. Of course, we are dividing by 22, but we're rounding the 22. Its front end is just the 2 in the tens place value. Immediately to its right is a 2 again. So the 2 in the tens place value stays a 2. And then every place value to its right becomes 0. So that's the ones place value. And again, we see that divide by 10 stuff, right? So I got zeros that match here. And I could rewrite this then as 40 divided by 2 now. So however you want to do it at this point is really up to you. We can show this with long division. You know, it's not really going to make a difference. 40 divided by 2. 2 goes into 4 there, well, twice. So then 2 times 2 is 4. So we used up the 4 from the tens place value, so we got 0 remaining. Now when we drop this 0 here, 2 goes into 0 exactly 0 times. And so 40, when we split it up into 2 equally, we get 20 as our quotient. I don't know if that looks better or not, but it's 20. So on this one, same idea, we need a front end round, right? So I'm looking at 299,995. But I just got the front end there in the 100,000s. Immediately to its right is a 9. That's bigger than 5. So I need to add 1 to the 2 in the hundreds place value to make that 3. And then again, all the other place values become zeros. There's 5 other place values there. Divide this by 27. We got a 2 in the tens place value. That's our front end. Immediately to its right is this 7, which is bigger than 5. So I got to add 1 to the 2 there. So that's going to make this 3. And then this other place value becomes 0. But again, we see zeros that match, so I can just simplify this just a little bit, which now makes this 30,000 divided by 3. So long division, or you can tack on the 0 thing. 3 goes into 3 evenly. That's true. However you want to look at it, you're going to end up with the same answer. So 30,000 divided by 3. 3 will go into 3 watts. So we would subtract 3 there to get 0. And then you got zeros all along the way in these other place values. And, well, 3 goes into 0. Any value goes into 0 exactly 0 times. So this would be our final quotient here, 10,000. That's a 1.